Alright, this is my first video about synthesis reactions, which is any reaction where two things combine to make a single thing. The easiest kind, and the part one that I will do with you, is two elements combining to make a compound. Now, if you're combining a metal with a non-metal, they will combine to make an ionic compound, because by definition, that is how ionic compounds are formed. What you really need to do is figure out what charge each of these atoms wants when it's in an ionic compound, and you'll need to consult the periodic table for that. Aluminum, being in this group, would prefer a charge of +3, and fluorine, which is what it's reacting with, prefers a charge of -1 because it is a halogen. Aluminum 3+ and fluorine 1- crisscross the charges to make AlF3. This is aluminum fluoride. All ionic compounds are solids at room temperature, and so you can safely put S, solid, for the state symbol here if your teacher requires that of you. Let's do a couple more so you can watch what I'm doing. Calcium wants a charge of +2 because it's in the alkaline earth metal group, and nitrogen wants a charge of -3. I'm even going to show you what I'm doing when I say crisscross the charges. That's Ca2+ as the preferred ion charge for calcium, and 3- for the preferred charge of nitrogen. I crisscross those, the 3 comes down here, the 2 comes down there, and I get Ca3 N2, also an ionic compound and also a solid. Do you need me to keep consulting this periodic table? Lithium wants a charge of +1 because it's in that first column. Oxygen wants a charge of -2. So what you end up with is LiO, crisscross charges, it's actually Li2O, lithium oxide. Potassium wants a charge of +1. Fluorine wants a charge of -1, and so it makes K1F1, that 1 and 1 crisscross, potassium fluoride, that's a solid. And magnesium wants a charge of 2+, it's in the same group as calcium. Oxygen wants a charge of 2-, we already talked about that. And those crisscross and cancel with each other to give us MgO. With ionic compounds, 2 and 2 will cancel with each other to make 1 and 1. MgO solid, that's magnesium oxide. Okay? Cool. Now, you in synthesis reactions will see pure element symbols here, and I just don't want you to get freaked out by some of them. All of the elements in this row that I've listed for you, and it spells Hofbrinkel, if your teacher taught it to you that way, have a little 2 underneath. That's simply because the pure elemental form of those elements is a diatomic molecule. It's very rare to see a Cl atom on its own in nature. Cl, in its pure form, prefers to be Cl2. Same with iodine, nitrogen, fluorine, bromine, hydrogen, oxygen. Elemental phosphorus makes a cluster of 4 atoms. Elemental sulfur makes a cluster of 8 atoms. And I just learned as I was researching for this that selenium also likes making clusters of 8, but I've never seen that before in any question I've ever answered in my entire life. So, you know, it's just for your information. Now, you may be asking what happens if you are given a transition metal, that's any of these, which can have multiple charges. Well, the actual answer to that is how much oxygen is around when you're doing the synthesis reaction, or, you know, how much of the non-metal is around when you're doing the synthesis reaction. Both should be acceptable unless your teacher has asked you to always use a particular charge for certain atoms. Some teachers will say always use the +2 charge or whatever. Anyways, copper can be +1. Oxygen's always -2. Copper can also be +2. And oxygen -2. When you crisscross these, it gives you 2 possible answers. One is Cu2O, and one is CuO. both solids because they're both metal-nonmetal ionic compounds. Both of these are acceptable. This is what is made if there is enough oxygen around, and if there isn't enough oxygen, it makes this less oxidized form. Anyways, let's play that game again. Fe can have a charge of +2 or +3. If you're wondering how I know these, it's because I've memorized them. You will either have a chart to refer to or you'll have to memorize them too, in which case, call me because we'll be one and the same. Crisscross 2 and 2 gives me 1 and 1, that's FeO. Crisscross 3 and 2, nothing cancels, that's Fe2O3. You may know that as rust, or iron 3 oxide. I'm going to do the same thing here with chlorine. Cobalt can be +2 or +3. Again, memorized. Chlorine is always -1, so you can end up with cobalt 2 chloride or cobalt 3 chloride. Both solids because they're ionic compounds. And I just want to throw out there that carbon can also be oxidized to various degrees to make carbon monoxide or carbon dioxide. You will recognize these more as combustion reactions, complete combustion and incomplete combustion, but they also, if you are making pure carbon monoxide, rare, or pure carbon dioxide, it counts as a synthesis reaction because two become one. All right, so let's review. I'll go back one page. Synthesis reactions are when two become one. Two elements making an ionic compound. Again, all the synthesis reactions, two things combine to make a single pure substance. In these cases, ionic compounds. These are the pure elements that are not just the elemental symbols. And let me point out that all of the metals, where'd my periodic table go? All the pure metals, that's from the staircase and over, except for hydrogen, which isn't a metal. All of their pure element symbols are just the elements themselves. You probably caught on to that when you saw these. And finally, when you're working with transition metals, which can have one or two or many different charges, the actual one that's formed depends on the chemistry of the reaction, how much of each thing you have around, etc., etc. Your teacher should give you guidance on which one he or she wants to see, but if they didn't, I don't know, do both. Throw them a curveball. Best of luck.